Alright, so let's take a look at our z-score, or what's also known as our standard score, and it kind of discuss and break down what this stands for. So standard score right here is also known as our z-score. Those are our two kind of given names for them. Now, what we want to remember about the standard score, the z-score, is it all ties back to that normal distribution curve. So, if we take a set of data, and we say, okay, well, that data point right there is our mean, and then we go up 3 times, 1, 2, 3. So that would be plus 1 standard deviation, plus 2 standard deviations, plus 3 standard deviations. We can go down, same distance, so equidistance, so minus 1 standard deviation, minus 2 standard deviations, and minus 3 standard deviations. And so if we kind of just remember those data points real quickly, we know that between these two guys right here, let's go a little bit higher with that. Between those two guys right there, that's going to be 68%. If we go between this guy and this guy, 2 standard deviations, that's 95%. And then last but not least, we go between 3 and 3, positive 3 and negative 3, and we know that that's going to be 99.7%. And so where we're going with this is that this is our normal distribution curve. This is that standard concept where we can say that we know that stuff will fall into these categories. Now, what the z-score does for us is, the reason I show you this is that obviously if we have a z-score of 1, then we know we're relatively close to the mean. Versus a z-score of 3, then we know that we are, not only are we above the mean, but we're quite a good distance, because we're almost 50% away from, we're that little teeny bit out here. So we're not very common, we're not very relatable to the mean, we're kind of outside the mean. So let's calculate this guy and see what it means. So we know what do we know right now. We know that our mean is 54.3. We know that our standard deviation is 6, and we know that our data value that we want to test is 49.5. So someone's calculated these for us. So someone had said, okay, we've got a set of data. We found the mean and the standard deviation, and now we want to take this 49.5 and figure out where it lands. Where does it land in relationship to the mean? So we plug it into our z-score formula. So z is equal to x minus the mean. This is a good formula to write down. It's very important. Remember that this would be for the population. So let me change colors here. This guy would be the formula for a population, because look, we're using Greek symbols. If we wanted to talk about a sample, we would use our sample notation, and so this guy right here would be for a sample. So make note, because you're going to use both of those throughout the homework and throughout the class. So we plug in what we know. Well, we know that we have our z is equal to 49.5 minus the mean, which is 54.3, divided by the standard deviation, which is 6. We pull up our calculator. And on our calculator, we start off, and a couple things here. I mean, what I recommend is just go ahead and do the division first. I'll show you a couple ways. So 49.5 minus 54. Got a little bit of lag there. My pen's not working right. Let's hope that comes back pretty quickly. Minus 54.3. Press enter, and then take that. So that's your numerator. So then we'll take that and we'll divide that by 6. And so we find out that we get a standard, or a z-score, a standard score of negative 0.8. So what does that mean? Well, that means that if we were to place this onto our normal distribution curve over here, if we were to place that, then we're basically looking at negative 0.8. We're looking for our data value would be somewhere around right there. So think about this. The mean is 54.3. Our data value is 49.5. And so we're pretty close to the mean. The smaller the standard deviation, the smaller the z-score, the closer that you are to the mean. Okay, so one more time. The smaller the z-score, the smaller the absolute value, whether it be negative or whether it be a positive, the smaller it is, the closer you'll be to the mean. And that gives you that idea of relative position in relationship to the mean. All right, that wraps up that question there on finding the z-score.